So we're going to look at question 5F10 from the book Dominic Donnellys Applied Maths. In this case, we're given a situation where two balls are coming along, and this lower ball is travelling at 3u and the top ball is travelling at 2u. They will get to a stage like this and they'll strike each other, and what we know is the distance between their lines of motion is 8 or over 5. At collision time, the distance between them on the hypotenuse of that will be 2 or, and so we bring it over here and we create a triangle that has that. Now what I've done is just that's it. So I'm now just trying to find out what this other side is, a bit of Pythagoras, and it comes out to be 6 or. So stop this video anytime you want and just check out where I'm at. Okay, so now we have the sides and we can determine the angle. In terms of the angles inside, or as I did here, seem to have, so I did turn it. So spin your axis for convenience. So now where our 2 or axis was here, it's now going to be running in the I-axis, so the centres of collision are there. So you can see the 3u and the 2u from that, and that angle on the inside that's marked, I calculated to be 53 degrees, and we'll get to that. So you're using, I just said that you're using the line of centres between the centres at collision as the I-axis. Then you can calculate the angle, as I just told you, is 53 degrees, or you can use similar triangles to figure out the ratio, and that's just sine and cos, and you should have enough experience at this stage in 6th year to get that done. So the 2u body therefore has turns out to be 3/5 of 2u I and 4/5 of 2u in j, and this is the diagram I ended up using, but it's not a great diagram. It's definitely not proportional. And then in the second one, the 3u particle is 3/5 of I and 4/5 of 3uj, and they're the same. Look at them. The factors are 3/5 and 4/5, and both. And the reason for that is because they're parallel in all cases. So if you want to solve the problem, you should draw a table, and this table is the MUV table, and in the U column you put in the complete initial conditions for both bodies, and the mass column you put in the mass. In this case, I said those are the same masses, so I just made that mass 1, and in the V column you put in the u of j, because that's not going to change because the collision is along the I-axis. That's why we shifted it this way. We didn't need to deal with all these formulas into axis. So so that's that. Fill that in yourself. I think I've made an error in this somewhere, and again, I'm not too worried because I do solve it, and I'm going to pick up most of the marks. Okay, so in the whenever we're doing these equations, we have to do the conservation of momentum. That formula is wrote there at the top. I told you I made m to be 1 because they're the same, and so I get 6/5 of u plus 9/5 of u is equal to p plus q. This is in the I direction, and so all the i's before add up to all the i's afterwards, really. The Newton's experimental law, V1 minus V2 over U1 minus U2 was equal to 5/6. They told us that. So V1 and V2 are actually P and Q. So I just cross multiplied here, and the 5 was handy because I got rid of that 3/5 and 4/5, or sorry, 6/5 and 9/5. And then a bit of simultaneous equations is probably where I went wrong. Found 12p was 99 over 5, so therefore p was equal to 99 over 60, and then q was equal to 69 over 60u. They look kind of right in my head, but they're not right in from the book. So they're not given in the book because it wasn't looking for velocities. It was looking for the speeds of the spheres after the impact. If you want to use the speeds, you have to go and solve the I and the j for both this. Whatever your p was down below, in my case 99 over 60 squared plus 12 over 5 squared, and get the root of all that, and you won't get if you do it my way, you solve it what I got, you won't get the right answer as given in the back of the book. Now, I never checked the solutions online, mainly because hopefully you'll find the error, but more importantly, I still solved it. I still solved the problem, mainly. There's another part to it that says show the angle between the paths approximately 20 degrees. So you just got to do your tan formula for that. I don't think that's the issue in this problem. Hope that helps. Bye.